Right, now we're going to talk about sediment produced by glacial erosion. And down here in Georgia, you might think to yourself, oh, well, glaciers aren't very common. They're only restricted to the highest elevations, the highest latitudes. Really, how important can glacial erosion be, glacial sediment be? And the answer is very important. We know at some point in time, the entire Earth was covered by glaciers. But even today, right, glaciers and ice sheets cover a pretty large percentage of the world, of our Earth. So much of the northern part of the northern hemisphere is presently covered by surficial deposits of sediment that were laid down during the retreat of the last ice sheet about 18,000 years ago. That was the last glacial maximum. So even in places where there's not glaciers today, we have to be able to understand and interpret glacial sediment that was laid down in the past. Glacial sediment is either directly deposited from the ice, and we call that till, or it's deposited from the meltwater that's melted away from the glaciers, carried that sediment farther away and deposited it elsewhere. And typically that deposit is stratified because you get that evidence of melting seasons and freezing seasons. And that material that's taken away from the ice sheet, is carried away by the meltwater, which means it's going to be the finer grained material, right? Whatever's finest can more easily be taken away. And you can see in this image that is from Alaska, just how much sediment is in the water coming off of these glaciers. Glaciers are an incredibly important sediment producing force, right? They're so erosive. And the really, really fine material that comes out of meltwater from glaciers we call glacial flour, because it really does look like flour floating in water. It can often be very bright white. And this can flow great distances away from the glacier. Now, if we go to the opposite end of the scale and we look at the biggest sediment produced from glaciers, you can get a glacial dropstone. So glaciers, as they're flowing downhill, can pick up these huge boulders and incorporate it into its ice, and then continue flowing downhill. And then that glacier will end up at the bottom of a valley. Eventually, that glacier will melt. It will drop those giant boulders that it's carrying, and then the glacier will retreat back up the mountain. So this giant boulder that kind of just looks erroneous, right, erratic out in the middle of this field where it doesn't really match anything else, is a glacial dropstone, right? It was dropped by the glacier.